Welcome to the Podkey summary of Expand the Capabilities of Your Virtualization app from WWDC 2026. A bunch of Apple virtualization tools just got a lot more practical, especially if you build or test macOS VMs for real work instead of demos. The big themes are less setup friction, better device and network control, smarter disk layering, and one very interesting new path for custom host-to-guest hardware communication. There's also a clear subtext running through all of this. Automation is great, right up until it quietly turns into a security problem. So a few of these features come with some very important guardrails. One of the nicest quality of life updates is in the Virtualization Framework's guest provisioning API for macOS. Apps can now hand over a full name, username, password, and optionally things like auto login or SSH enablement, and that gets injected into Setup Assistant on the VM's first boot. So instead of clicking through first run screens every single time, the VM can come up already configured with an account, which is exactly the kind of boring repetition automation should eliminate. There is one important catch. This is really a first boot tool. If the guest already has a user account, those provisioning options are ignored on later boots, so developers need to treat this as one-time setup logic and design around that. And of course, the password part deserves a giant fluorescent sticky note. Don't hard-code credentials into the app. Pull them from the keychain, an external config file, or environment variables, because once secrets start living in source code, they somehow become immortal. That security angle goes beyond just password storage. Provisioning data is being passed into the guest during boot, so you really want to make sure only trusted code is able to invoke those APIs. And if you're turning on SSH for a freshly created VM, that's convenient, but it also changes the exposure of that machine immediately. Automation tends to feel harmless, because it removes clicks. But sometimes those clicks were the moment where a human noticed what was happening. Accessory access is another very practical addition, this time for USB pass-through. Instead of a hidden or confusing flow, there's an explicit, user-visible control model. A menu bar extra shows, matching USB devices, and the user can attach or detach them from a running VM. That matters, because USB ownership can get messy fast, and this makes the handoff feel much more understandable. When a device is handed to the guest, the host automatically unmounts it first. When it comes back, the host remounts it. It also supports hot plugging, so this is meant to behave like real hardware usage, not a static boot time trick. Under the hood, apps register matching criteria with AAUSB SASRI matching criteria, and once a device is attached, they create a VZUSBP pass-through device on the VM's USB controller. Then detaching gives that device back to the host cleanly. It's one of those features that sounds small until you remember how annoying device pass-through usually is. The VMnet framework is where things start getting more ambitious. Developers can define isolated NAT or bridge networks, customize DHCP settings, and add port forwarding rules, which means you're no longer stuck with one bland default network shape. That opens the door to more realistic multi-VM setups, like testing a client and server across separate subnets, or building isolated environments that still expose a few carefully chosen ports. Basically, you can model the network you actually need, instead of pretending every system lives on the same polite little island. There's an implementation detail here that matters a lot. A VMnet network object is reference counted and it is not automatically persisted. So if an app wants that network to survive across launches, it has to serialize the configuration with VMnet _network_copy_serialization and restore it later. And if VMs live in separate processes, that same serialized config can be shared over XPC, so they connect to the same virtual network instead of ending up in parallel universes. Disk Image Kit also got a useful upgrade with support for the Apple Sparse Image Format, or ASIF, and stacked image layers. The basic idea is that you can have a base image, which can be RAW or ASIF, and then put upper layers on top as cache or overlay ASIF images. That gives you copy-on-write snapshots and read caching without duplicating the entire disk file every time you want a variation. Overstart layers, capture writes, which is great for snapshot-style workflows. Cache layers store frequently accessed blocks to improve read speed, which is a nice reminder that storage performance problems are often just traffic problems wearing a fake mustache. Apple's guidance here is pretty straightforward. Shallow image stacks perform best. So yes, layering is powerful, but this is not an invitation to build a 12-layer disk lasagna and act surprised when it gets sluggish. A read-only base image can also be shared across multiple VMs, which cuts storage overhead nicely when lots of machines start from the same foundation. The most developer-heavy addition here is probably VZ Custom Virtio device in macOS 27. This lets apps define custom Virtio devices with their own PCI class, queues, and delegate callbacks. In plain language, it means you can create a specialized virtual device for high-throughput, low-latency communication between host and guest. Apple's examples for that kind of workload include things like crypto coprocessors or machine learning accelerators, which makes sense because those are exactly the cases where generic plumbing can become the bottleneck. There is a pretty major requirement attached, though. The guest needs a matching driver. The host delegate handles in-queued buffers and can trigger guest interrupts. So there's real flexibility here, but also real systems work. And the performance advice is the usual good Virtio advice. Minimize context switches, keep the queues efficient, and don't accidentally design a high-speed path that trips over itself every 5 feet. Taken together, these updates make Apple's VM stack feel more like a toolkit for building complete environments instead of just spinning up isolated machines. You can provision the guest automatically, hand USB devices in and out with clear user control, build more realistic networks, avoid bloated duplicate disk images, and even define custom virtual hardware when the standard pieces aren't enough. That's a pretty coherent story, and it's a useful one for testing, development, and specialized workloads where the details around the VM matter just as much as the VM itself. So the short version is, less click-through setup, more control, and a lot more room for serious VM workflows on Apple platforms. Just keep the secrets out of your source code, keep your image stack shallow, and maybe don't hand a brand new VM an SSH door unless you mean it. This episode was generated by Podkey. Create your own at podkey.fm.